Lesson 9. NAT. Network Address Translation. In this video lesson, guys, we'll describe with you how to work with NAT, what is the purpose of the usage of the NAT, and how to make configuration of NAT on the Cisco router. Let's first of all start from that moment where we have the division of the private and the public IP addresses in IP version 4 addressing. And the private addresses, we have three ranges for the private addresses. So these IP addresses, like 10 to 10.255, have to be used inside local area network. These IP addresses also have to be used inside local area network, and the last range of the private addresses have to be used only inside local area network. And one of the reasons why engineers created public and private IP addresses, IP version 4 addresses, the reason of it is that we can save the IP address range, because you know that we have in IP version 4, we have with you 32 bits. And by using 32 bits, we can have 2 to the power of 32. Which is giving you approximately 4 billion and something IP addresses. And imagine that you have you are a user of the internet and you have some equipments. For example, I have one notebook, one computer, and one smartphone, and these three devices are connected to the internet. And in case if all the people will just use the internet with their equipments, and if their equipments will have different IP addresses, so in this case, so we have approximately 7 billion of the population in the world, and also if each of them will use approximately by 3 or 2 equipments, then it will be much more than 4 billions. And also, we have a lot of services which are, we have a lot of servers which are also using IP addresses. And in this case, to save the range of useful IP version 4 addresses, engineers say that, alright, we will use private IP addresses in local area networks, but when our devices will be connected to the internet, we will use the public address. So that we may have such kind of situation that our company will be connected to the internet, and inside our company we will use the IP addresses like 192 and 10. So these two addresses are from the range of the private addresses. And in the internet, when we will be connected to the ISP, to the internet, we'll use one of the public address. For example, it will be 777 and 1. So this IP address is in the range of the public IP addresses. So imagine that we have connectivity to the internet, and here we have our router of another local area network, and we will be connected to the switch. Switch will be connected to computers, and in here, so we have with you computer A and computer B. They will have IP addresses like 192.168.10.10 and 192.168.10.11, for example. And as you see here, so this area also belongs to local area network. And this is one organization, so for example, organization A, and this is organization B. And in two organizations, inside these two organizations, we have local area network IP addresses which are common, not the common, which are absolutely same. But when these computers will try to make communication, for example, when PC1 will try to make communication with the internet area, when it will exit, its source IP address will be changed from, so as you see here, we have a packet with the source IP address 192.168.10.10, and destination IP address, for example, is going to be the IP address of the server. 209.165.165.201 and 1. So PCA wants to contact the server. When this packet will leave the router 2, if it is connected, if it is configured with NAT, NAT will change the packet source IP address from 192.168.10.10 to 7771, and destination IP address will be the same, so it will be 209.201.1, so that when server will receive the packet, it will think that it is making communication with this IP address. Okay, and a lot of computers from this organization can exit from the network through single IP address by using the functionality of the NAT. And even these two computers, which have absolutely same IP addresses in local area networks, they can also have the communication between each other by changing their IP addresses. Now let's take a look for the NAT terminology, in which you may find out the 4 types of IP version 4 addresses. They are, we have inside local address. It is original source address, which belongs to that device which is generating the communication. Then we have outside local address. It is destination IP address. So in our example, web server is outside local address. So we want to contact from inside address to outside local address. And when our packet will leave the router in which we have functionality of the NAT, NAT will change our inside local address to inside global address. And for example, it is 209.165.200 and 226. So this source IP address will be inside this packet. And outside global address is the same as the outside local address. Why they are same? Because in other side, in the ISP, we don't have any translation. But in case when you are making one NAT translation in your organization and another NAT translation in that organization to which you are contacting, then you will have double NAT translation, and due to that fact that you have double NAT translation, your outside local address and outside global addresses can be different. But in this situation, they are same due to that fact that we don't have second NAT translation. So that when our PC1 communicates with the server, so look, when our PC generates the communication, its IP address is 1010. The packet's IP address. When it is leaving the network through the router to where we are going to make configuration of NAT, its IP address is going to be changed to inside global IP address. And when we have a reply from the web server, whereas web server is creating the communication, and while it is creating the communication, its inside global IP address is just a moment, not the inside, it's inside. Where is that? So here's this. It's outside global IP address and outside local IP addresses are going to be same again, because we don't have here a translation. But again, our server will send information to inside global IP address, to this IP address, and then router will take this information and will redirect it by NAT to inside local IP address, and our communication will be done through the NAT. And in a router we have a RAM memory, and inside RAM memory we have NAT table, which is created right after your packet is passing through this router. And only router knows which IP address is translated to which IP address. And one of the reasons also of using NAT is the security purpose, due to that fact that no one else from the outside network is able to recognize what is your original IP address. And now it's time to take a look for NAT in action. So here we have a small animation from netacad.com, Cisco Networking Academy website. So as you see, our source IP address is 192.168.10 and 10, and when it's going to be reach R2, so approximately in R2 we have not configured, and it will be translated from inside local address to outside local address. And as you see, our source IP address is going to be changed, and then a server will give reply to this IP address. Router will make translation back to original and will send it to that computer which created this communication. We have three types of NAT. We have static NAT, when we can translate one IP address to another IP address. For example, we have one local address like this, 1010, and when we will try to exit through the network, it will be translated, for example, to our IP address, which is outside local inside global IP address. So this IP address will be inside local, this IP address will be inside global. Also, we can make translation of, so like dynamic, it is many to many. We can create the list of IP addresses which we want to translate to another IP addresses. For example, starting from 1010 until 192.168.10 and 20, for example, they will be translated to the range of IP addresses of 7771 until 777 and 10 or 11. Yeah, 11. It will be quite enough. So that when we are making such kind of translation, we have to be sure that we have ability to use these public IP addresses, because each public IP address which is reserved by you have to be paid by you. And also we have a mostly used translation type. It is called port address translation, where you have many IP addresses, like you have a local area network with such kind of network with prefix 24, and you want to make translation of all these IP addresses into single IP address which you have in your home, like this. Okay, actually a lot of customers which are using the services of internet service provider at home, they are using the NAT type, which is called PAT, port address translation. It's time to take a look how we can make configuration of static NAT, in which in this example we have with you IP address of PC0, and its IP address will be translated when our packet will try to exit from the network, and we'll translate it by using the command IP NAT inside source static. It is defining that we are going to make one-to-one translation, and we are translating our inside local address to inside global address. So it means that when packet will enter to the router, it will enter with source IP address like this. But when it will exit to the router, it will exit the router with this source IP address. And look guys, in case if PC0 will try to make communication, its packet will be changed. So new source IP address will be added here, 1, 1, 1, and 1. But when PC1 will try to make communication, it will just leave with the same source IP address, like 192.168.10 and 112. So what will be happen if our packet will try to leave through the router to the public network with the private IP, with the private source IP address. Then this packet will be destroyed in the cluster. It will be destroyed in the internet service provider side, or even you can destroy it on this interface by using access control list, so that you can permit only those packages which source IP addresses are public, like this, so that PC1 will not be able to communicate through the internet, but PC0 will be able to do it due to the fact that we configured the static NAT. Then we have to define that gigabit 01 interface will be the part of the private network. We have to say this is inside address, and we have to say to our NAT that S000 is the outside address by using commands interface gigabit 01 IP NAT inside. We can exit, we can just type it without exit, interface S00 IP NAT outside. Let's try to implement this example in, and here it is. The same example as we had in the presentation. Well, we have to be sure that first of all our communication is proper between PC0 and server 0. Well, we lost our packet, maybe because of the ARP requests. Yeah, now it is successful. And PC1 is also going to be successful. And if we'll take a look for the simulation with you guys, in the simulation we have to make filtration by the ICMP packages because we want to see the ping in process. Let's take a look how our packet is traveling from PC0 to server 0. First of all, we'll click to the first packet in which we can see source IP address 10.111 and destination IP address 209.165.201 and 10. And now we will make such kind of thing like we'll close this packet information and capture forward. So when our packet will leave the router now, we'll catch this packet and we'll see that our source IP address is still 10 and 111 and our destination IP address is looking in the same way, so that our packet is not translated, its source IP address is not changed. And if we'll try to make the same thing through PC1 to server 0, we have to see the same situation, so that when packet will leave the router 0, it will see that its source IP address is absolutely same as it was in the original, and it means that this type of communication have to be failed actually in our cluster, because there is the internet service provider who have to restrict such kind of communication with the source IP address, which is in the private range of IP addresses. And now we have to create the configuration of NAT. To do this configuration, we have to go to global configuration mode, and in global configuration mode we will type the command which is creating an a network address translation list, so that we are creating IP NAT inside source, and we have to type here static because we want to make one-to-one translation. And let's say that so you see here inside local IP address, so we have to type our IP address, which is going to be IP address of the original equipment, and then we will change this IP address to, for example, IP address of our interface 111 and 1. Then we have to go to configure interface gigabit 01 IP NAT inside, and then interface gigabit serial 00 and 0 IP NAT outside. Then we just configure two of our interfaces with the NAT, so that now routers interfaces know which of them is connected to the inside local area network and which of them is connected to the public network. We firstly have to verify that we just configured everything properly. We can type command show run, which is going to show us our translation. And here we have, oh, by the way, I have here some previous configurations, so let me delete it. Now I don't need them. So I have to open the notepad and paste these configurations with the command no. Sorry for that, guys. And let me copy it and paste it into the global configuration mode and show and let me type show running configuration file command, and now I have to see here that my NAT is configured, and only that configuration which I create right now is appearing here. IP NAT inside source static and translate this address into this address. And then also I have to check my interfaces so that they have to be properly configured. Interface gigabit 01 have to be configured as IP NAT inside. Yes, it is done. And serial interface 000 will be configured as IP NAT outside. It's also done. Now it's time to check will my translation be happening or not. So that I'm just creating a packet, a simple PDU packet, which is going from PC0 to server 0. When this packet is generated, its source IP address is 10 and 111. When this packet will reach the router and will exit the router, its IP address, source IP address, have to be changed to, as you see here, 1, 1, 1, and 1. Well, our translation is working, so let's take a look that our packet can reach the server 0, and when server 0 gives reply, it gives reply to destination IP address, which is equal to 1, 1, 1, and 1. But when this packet will reach the router will retranslate it back, and now our destination IP address will be equal to the original destination, 192.168.10 and 111. Well, you have ability also to check your statistics in the router, so you can type show IP NAT translations, and afterward you may find out here that your inside local IP address and inside global IP addresses are matched in this table, whereas outside local and outside global IP address is absolutely same IP address here, because we don't have a second NAT on the other side of our communication. And at the same time we'll try to make ping from PC1 to server 0 so that its source IP address will be 100, so 10 and 112. And when this packet will exit through the router 0, its source IP address doesn't have to be changed, so it is absolutely same, 10 and 112. And let us make such kind of ACL list which will deny communication from all private addresses, so that we can go to cluster. So in cluster we have just only one router and one switch, and we can even delete this cluster. When we are deleting cluster, we can uncluster our cluster so that it's like ungrouping, and then we will see that we have inside just basic router and the switch. Well, I opened the secret for you. What do we have in our cluster? And now it's time to make such kind of filtration on router 1, which will say that no private addresses. Okay, so that we can even create such kind of access list, which will be called no private addresses. No private addresses, like this. How we can create this access list? So we can just write this access list like this. So IP access list standard. So I'm going to create the NACL, name it ACL, so let me do it in Notepad. And then I will say that my IP address name will be no private addresses. And then inside my access list I can type the comment which will permit network address like 192.1, I'm sorry, which will deny, first of all I have to deny 192.168. Alright, let me also take a look for my presentation in which I have to see all my private addresses. Here are they. I have to define my private addresses. Deny 10.0.0.0 with wildcard mask of prefix 8. Then deny 172.1.6.0.0 with the wildcard mask of prefix 12. So I have to find out what is going to be the wildcard mask of prefix 12. To find it out, we first of all have to find out what will be equal to the subnet mask. And from subnet mask we can find out with you what will be the inverse subnet mask. Well, we have 12 bits. 12 bits, it is 8 bits and 4 bits and 0 and 0 in the 32 bits range area. So that 8 bits in a row, it is 255. Then we have 4 bits in a row, 128 plus 64 plus 32 plus 16 will give us 192, 224 and 240. So our subnet mask will be 240.0.0. To find out the wildcard mask which we want to list in access list, we have to make subtraction of this value. I mean, we have to make subtraction of full subnet mask 255, 255, 255 and 255 from our subnet mask. So as a result we'll get 0, 15, 255 and 255. So this subnet mask have to be used by us to define prefix 12. 0, 15, 255, 255. Next we'll deny communication from 192.168.0.0 with wildcard mask of prefix 16. And then we have to say permit any, because all other communication have to be allowed. So let me copy this access list configuration and let me go to router 1. In router 1 I have to go to global configuration mode and I have to paste, I have to click the paste button. And here it is. Here's my no private IP addresses access list. Now I have to implement it or to inbound ACL or to outbound ACL. I prefer to use it as the inbound ACL. Interface S00, let's take a look, 0, 0, 0, 0 will be configured as access group no private addresses in. Well, I think that I forget to type the command IP access group. And now I have to check my running configuration file, which is going to show me that interface S000 is configured with the access list in, and I have to also find out my access list, which is denying all communication from this type of IP addresses and which is permitting all communication to all other source IP addresses. Now let me check my access list in the simulation so that I will send information from PC 0 to server 0. Well, its IP address have to be changed in router 2 so that we can find out here that our source IP address is 1111 and it have to be available so it can reach the server 0 due to that fact that it can pass through this filtration of the private source IP addresses, and our reply will be successful delivered to PC0. But in case if we'll try to make communication from PC0 to server, from PC1 to server 0, its IP address will not be changed, so it is coming with this. Oh, so look, here we have no, so I have to go back. Yeah, when it is leaving the router, its source IP address is same, 192.168.10 and 112. It is not changed, as you see. Due to that fact that if it is not changed, our router makes filtration and find out that this packet is not available to pass to server 0, and then it will send the message which is saying that destination host unreachable. So that in case if you will type this IP address in the ping on the command prompt, like ping 209.165.10, or let me take a look, 201 and 10, what kind of reply you will see? So it is delivered, destination host unreachable, and who have sent this information? The next router 1's IP address. As you see, this IP address belonged to router 1. So if you'll take a look for router 1's configuration, like show IP interface brief command, you will see that the serial 000 has this IP address. Alright, now we can see how NAT protocol can impact to our configuration, to our communication between networks from the private network to the public network. And now it's time to follow our presentation. Multiple static NATs. We can also make configuration of NAT multiple times. And to do this job, we have to just type one more time the command ipnat inside source static, but additionally we'll add here information about second IP address, which will be converted, which will be translated to another IP address. So that, as example, I placed here IP address 10. You may ask me, we don't have this IP address on our interface, but it doesn't matter. You can make translation to any IP address, but it will be better if you will use that IP address which belongs to you, I mean which you reserved from the internet service provider. And then we will just do the same job for our interfaces. It means that this part is already configured by us. This part is also already configured by us, so that if we want to have access from PC1 to server 0, we just need to type our second row, which is creating a new NAT. In router 0, we'll go to make configuration of our NAT inside source static, and then we have to provide IP address of our second computer, and its inside global IP address will be looking like, for example, 10. And then we have to take a look for the running configuration file, including the NAT, so that we can see here that we have new translation, which will be done especially for this computer, which has an IP address 112. It's time to check, will PC1 now be able to communicate with a server 0? Previously it didn't have ability to make communication because we had ACL, which made up this filtration. So now PC1 will send information, and look, and this successful. So here it is. And if we'll take a look for the packet which we'll capture after it will exit the router, we'll see that its source IP address is 111 and 10. But the packet which will leave the PC0, and when the packet will be captured when it will leave router 0, we'll be able to see that its source IP address is 111 and 1. This is how we can make with you the configuration of multiple static NATs.